All right, guys, so kind of a quick video today. I'm going to try and keep this simple because at its core, it really is a simple idea. So what we're doing today is we're still finding volume, but instead of taking a shape and rotating it through space and adding up all the areas, we are taking kind of like 3D Riemann sums. All right, so basically what you've seen and some of what we've done looks like the picture we have right here. We've got two curves and we've got this line in between them, right? And we've been doing top curve minus the bottom curve, and you've been integrating to find the distance that something travels or the total amount of area, right? Well, what we're doing different today is on top of this line, instead of this just being a line that's moving back and forth, we are going to build a shape on top of it. And it's going to tell you what to build. It's going to give you the bottom, the base, and it's going to look like what you see here. And then it's going to say, hey, we want you to take cross sections of squares, which means on top of that line is going to be a three-dimensional square. And so when we integrate and go from left to right, we're not just integrating the distance between those 2 points. We're integrating how that distance changes the area of this shape sitting on top. And what's cool about that is as you are integrating, as you are taking all of these square areas and you're adding them together, what you end up with when you're done is that three-dimensional shape. So when you're done, you end up with a volume. You end up with this three-dimensional shape, this volume, and it doesn't matter what they are going to do. Is they're going to give you this base, and the shape on top is going to change. They might say, hey, we want you to put equilateral triangles on top, and we want you to do cross sections, and so you're going to find the volume of a shape, and the bottom is that base, and the shapes that are sitting on top of our line that are hard to see now because I traced it, those, hey, go away. Those shapes are triangles, right? An equilateral triangle. So our goal today, what we need to learn how to do is take this top minus bottom, take that line, and instead of just using that line itself, we are going to use that line to create an area formula so that when we integrate, we add all these shapes together. So going back to the notes, you've got some formulas. Number one right here says that for cross sections of area A of x taken perpendicular to the x-axis, you are going to use the integral from a to b of ax. Now the a to b, those are just x values like they've always been. Ax, that is going to be the area formula for whatever shape it wants you to use. So if you're going perpendicular to x, you're using x values and an area formula, and you would want that in terms of x, right? For cross sections that are perpendicular to the y-axis, exact same thing, but we are going to use y values. And when we do our area formula, it needs to be in terms of y instead of in terms of x. So here's what it looks like. Okay, let's do an example. Find the volume of the solid whose region is bounded by f of x equals 2 minus x squared over 2, g of x equals negative 2 plus x over 2. So what that looks like, if I were to draw this, so I'm going up 2, and I've got a negative slope of a half. So I'm going over 2 and then over 2 more. So this one is not even close. Wow, that was so bad. So this one looks something like this, right? So there is my f of x. That's my 2 minus x over 2. Then it wants me to use g of x, which is negative 2. So I start down here, and I'm going up 1 over 2. So it's this one. So this is my g of x. This is my negative 2 plus x halves. And then it wants me to also bound this by x equals 0. So basically, I've got this. This is the bottom of my shape. Okay, this is the base. And it wants me to use cross sections perpendicular to the x-axis. So I'm going to use x values, and it wants me to use equilateral triangles. So we are going, on top of this shape, we are going to build equilateral triangles to find the volume. So what that tells me is I need to integrate, and I'm going to use x values, and I need the formula for the area of an equilateral triangle. That's what's going to go inside my integral. Now, the way that you do this, and what we need to be careful of, I'm going to go back to our little app here. What you need to be careful of is, as we are waiting for this to load. Okay, here we go. As I'm doing this equilateral triangle, as I'm going left and right, the only value I have to work with is the distance between the top and the bottom curve. And that is going to change as I move left and right. Maybe it's a little easier to see at an angle. That is going to change the size and the area of my triangle. So what I need to do is write the area of a triangle formula, but it needs to be in terms of only the base. So what that means is, normally the area of a triangle is 1/2 the base times the height. That's not going to work because I don't know the height of my triangle. And in fact, my height is going to change as I take my integral and my base changes. So I need to come up with a formula that doesn't have base and height. I need to do this with only the base. And I'm going to walk you through one of these. We're not going to do this every time. In fact, some of these formulas you'll start to memorize pretty good. But if I think about an equilateral triangle, and I'm going to call the bottom the base, then these sides are also the same length, right? They're also the base. Now, to find the area, I would normally use this height right here, but I don't know the height. So I'm going to make this a 90-degree triangle, and I'm going to use half of my triangle, all right? We're going to call this b over 2. So I'm only focusing on this right here. Using that triangle, I can solve h, because I know that h squared plus b over 2 squared is equal to b squared, right? I've got the Pythagorean Theorem. So that means that h squared plus b squared over 4 is equal to b squared. So h squared equals b squared minus b squared over 4. And you know what? Let's h squared equals b squared. Whoa, don't square root yet. What am I doing? B squared times 1 minus a fourth. And 1 minus a fourth is 3/4. So h squared equals b squared times 3/4. And when I get h alone, I'm trying to solve for h right now because I want to get rid of h. When I get h alone, I take the square root of both sides. So h is equal to, the square root of b squared is b. The square root of 3 is square root of 3. The square root of 4 is 2. So my height, I can write my height as b square root 3 over 2. And the nice thing about that is, up here I can replace my height now with b times the square root of 3 over 2. So this formula is, let's clean it up because that's going to drive me crazy even. So my area formula is now what? Root 3 over 4 b squared. So that's the area formula for an equilateral triangle, and we no longer have to deal with the height. There's no more height involved. All I've got is b. So when I write my integral, I'm going to use that area formula. So that square root 3 over 4, I'm going to move it to the front, and the b squared is going to change a little bit. Because my b is going to change. As I integrate, this is where we do top minus bottom. My b is the top curve minus the bottom curve, and that's going to change depending on where I'm at. So I rewrite this, root 3 over 4 integral. my top curve was my -2 plus x over 2. And I have to minus my bottom curve, which was 2 minus x over 2. And all of that has to get squared because my formula for area wants me to square it. And then I've got a dx right here. And I'm missing, what am I missing? Oh, my limits. So when I look at my picture, I am going from here to this point, which is 4. So I'm going from 0 to 4. And some of you are going to want to clean this up. This would be a great place to stop and just put all of this in your calculator. Stop right where you are. Make your calculator look just like this, because I promise you this will be a calculator question. And I don't even remember what the answer is, so I don't have it written down anywhere. You'll have to come up with that. Next one. Let's do, I think we're just going to do one more, and we'll maybe practice some more in class, but we can finally do part C on this AP question. So if you don't remember, we had this curve. This weird curve up on top is 20 over 1 plus x squared. R is the region that's in between. That is a positive 2. R is that region right there. And why do I have so many extra things in my picture? What it wants us to do on part C is the region R is the base of the solid. For this solid, the cross sections are going to be perpendicular to X, and it wants us to make semicircles. Okay, so that means my area formula that I'm going to use is the area of a semicircle. Well, the area of a circle is pi r squared. A semicircle is half of that, so 1/2 pi r squared. Now, I like this a lot better than my area of an equilateral triangle because I only have one variable, radius. But I need to be careful, and maybe this is why I put those dashed lines, because when you think about taking the integral and I take my top curve minus my bottom curve, that distance is not going to give me the radius. That distance right there is going to give me the diameter. But my formula wants me to use radius. So I need to fix that. And the way that I do that, instead of radius, because 1/2 my diameter is what my radius is, and I'm going to be using diameter in my integral. So let's replace r with 1/2 the diameter. So my new formula, area of a triangle, is 1/2 pi, and instead of radius squared, we're going to take 1/2 diameter squared. And that I'm going to probably clean up. If that was my final answer, I might leave it like it is, but I have to use this formula in an integral. So I do want to simplify this a little bit. I don't have to, but I want to because this bugs me. And it'll be a lot easier to plug it in if it looks nice. So my formula becomes 1/2 pi. This becomes 1/4 d squared, which ends up being 1/8 pi d squared, or pi over 8 d squared. I like those a lot better. So those are my area formulas for my, that wasn't a triangle, that was a half circle. Those are my area formulas. So when I do my integral, I know I'm going from -3 to +3. I need to plug in my area formula. So if I use this right here for my formula, the pi over 8, that's just a constant that can go in front. This part is d squared. Well, d is going to change, right? D isn't d, that doesn't mean anything to me, because d is going to get bigger and smaller as I integrate. So I'm going to rewrite this from -3 to 3, and I'm going to turn this into top minus bottom. Okay, this is the same pattern we're going to go through over and over again. So I'm going to take my top curve, 20 over 1 plus x squared, and I'm going to minus my bottom curve, which is just 2. That's nice. And my formula says I need to square that area. Now everything is in x's, and this looks like an integral that I know how to work with. And by know how to work with, I mean I know how to plug it in my calculator because I'm not going to do that by hand. The way the scoring is going to work on this, whatever your answer is, it's like 170-ish. It's something like that. I can't remember. That answer would give you 1 point. You would also get a point, or 2 points, sorry. You get 2 points for the integral, which means this entire piece needs to be done accurately to get the 2 points. You don't get 1 point for different parts. You have to get all of the parts correct to get 2 points.